The formula for the quotient rule is g dx of u divided by v is equal to u prime v minus u v prime all over v squared, where u and v are functions in x. So for example, if you want to get the derivative of 1 plus 3x over x squared plus 1, we make the numerator as u, so u equals 1 plus 3x, in which case u prime, the derivative, is 3. Make the denominator as v, so v is x squared plus 1, and v prime is 2x. And the next step will just be substitution into the formula, so that's u prime, which is 3, times v, which is x squared plus 1, minus u, which is 1 plus 3x, times v prime, which is 2x, all over x squared plus 1 squared. When dealing with derivatives, there's usually no need to expand the denominator, so we are going to keep it as x squared plus 1 to the power of 2 for now. But we sure can clean up the numerator a little bit, so it will be 3x squared plus 3 minus 2x minus 6x squared all over x squared plus 1 squared. Simplify it a little bit more as negative 3x squared minus 2x plus 3 all over x squared plus 1, and you can keep your answer that way. Let's have another example. Suppose you want to get the derivative of x squared minus 3 over 3x minus x squared. Let's make the denominator as u, so x squared minus 3, so the derivative is 2x. Make the denominator v, 3x minus x squared. The derivative will be 3 minus 2x. Then substitute into the formula. The derivative would be u prime times v minus u times v prime all over 3x minus x. So that's 3x minus x squared squared. So again, there's no need to expand the denominator, but let's simplify the numerator a little bit. So here, x cubed will actually cancel out. So we will have 6x squared minus 3x squared, so that's 3x squared, then minus 6x plus 9 all over 3x minus x squared squared. And it is okay to leave your answer that way. Let's take one last example. So here we have the square root of x over 1 minus 2x, quantity squared, and we are going to get the derivative. So like the previous examples, we are going to make the numerator as u, but we write it as x to the power of 1/2, so that u prime will be 1/2 x to the negative 1/2. Then let's make the denominator as v, that's 1 minus 2x power of 2. To get the derivative here, you could expand this and then get the derivative, the individual derivative of each term. But I would suggest that when you are doing the quotient rule, in this case, use the chain rule so that it will be easier to simplify, and later on, if there is a common factor between the numerator and denominator, it is easy to keep v prime in this case in factored form. So we're going to use the chain rule shortcut for power. So that will be 2 times 1 minus 2x power of 1 times negative 2. So that will be, just simplify this as negative 4 times 1 minus 2x and keep it that way. Don't expand it. And then substitute into the formula. So u prime 1/2 x negative 1/2. Okay, let me do it here. U prime is 1/2 x negative 1/2. V is 1 minus 2x power of 2 minus u is x to the 1/2 times v prime will be, okay, let's use a bracket here, square bracket, negative 4 times 1 minus 2x. Everything, so that's all over 1 minus 2x. 1 minus 2x squared raised to the power of 2, that will be raised to the power of 4. Now the numerator here needs a bit of simplifying. First, just a quick review. Suppose you have, let's say 2x squared plus 4x. When you're asked to factorize this or to express this in factored form, we just take the common factor 2. And so we write this. Actually, let me change this as just 2x squared plus 4. If we express this in factored form, we just factor out the common factor 2 and then divide each term by the common factor. So 2x squared divided by 2 is x squared, and 4 divided by 2 is 2. Now notice that between 2 and 4, the common factor is the smaller of the two. It's going to be similar when you have fractions. So in our numerator here, for example, we have 1/2, and no, actually, let me rewrite the numerator before I do this step that I was about to do. Let's rewrite the numerator first as 1/2 x negative 1/2. You just need to get rid of that square bracket there in the second group. 1 minus 2x squared. Let's write the second group as plus 4x to the power of 1/2 times 1 minus 2x. And then keep everything as they are. 1 minus 2x power of 4. So now I was about to say what I was about to do earlier was to factorize, to look at the number 1/2 here and 4. So since 1/2 is smaller than 4, we could take it out as our common factor. And also, if you remember when you're asked to factor out something like x cubed plus x to the power of 5, we factor out x cubed, so the common factor here is x cubed. So when we take that out, the next step will be to divide each term by the common factor. So x cubed divided by x cubed is 1. X to the power of 5 divided by x cubed is x squared. The same principle works for when you have fractional exponents. So if we look at x to the power of negative 1/2 here, for example, and x to the power of positive 1/2, the same thing here that we did here is we chose the smaller exponent. We also choose the smaller exponent. So because negative 1/2 is smaller than positive 1/2, we take out x to the power of negative 1/2, the smaller exponent, as the common factor. Now as for 1 minus 2x, you have 1 minus 2x, we have 1 minus 2x squared here, so there are two of them, and here you only have 1. So the common factor is the one with the smaller exponent. So the common factor here is 1 minus 2x. So 1 minus 2x. So once you have sorted out the common factor, which is this, we are now going to divide each group by the common factor. So the first group, if we divide it by the common factor, 1/2 divided by 1/2 is 1, so it sort of goes away. Same with x to the power of negative 1/2, and x to the power of negative 1/2 here, that's 1, so it goes away. But when we divide this 1 minus 2x to the power of 2 by 1 minus 2x to the power of 1, we are left with 1 minus 2x to the power of 1. So that's the first group. For the second group, we divide this. I'm just going to put this plus sign over here. When we divide this second group by the common factor, so it will be 4 divided by 1/2, which is 8. And then x to the power of 1/2 divided by x to the power of negative 1/2. Let's write that down. X to the power of 1/2 divided by x to the power of negative 1/2. So we copy the base and subtract the exponents. So 1/2 minus negative 1/2 is actually just 1. So x to the power of 1/2 divided by x to the power of negative 1/2 is just x. And then 1 minus 2x divided by 1 minus 2x is 1. So we have this, which is much simpler. And then keep the denominator as 1 minus 2x power of 4. So now we actually have this much simpler expression. And remember that 1/2 x to the negative 1/2 is like 1/2 times 1 over x to the power of positive 1/2, which is 1 over 2 root x. So now we could write this as, okay, and also we could notice that we have 1 minus 2x to the power of 1 here and 1 minus 2x to the power of 4 in the denominator. You could cancel out 1 here, one common factor. So now we could write this as much simpler. 1, we are now just left with, so the numerator, we could put this as a denominator because of this. So what we have left is 1 plus 6x. And then the denominator will be, this whole thing is just 1 over 2 root x. So 2 root x will be a denominator. And then times 1 minus 2x to the power of 3. And that is your answer. Numerator, we are now, for the numerator,